In this video, we're going to continue to learn how to solve quadratic equations. In the previous video, we learned how to factor by common factoring, and by common factoring, we were able to guess the solutions to the equation. And we're going to continue with another technique of factoring called decomposition, and a shortcut to decomposition, which is called sum and product, that we can use in certain circumstances. So let's just review how to solve quadratic equations once they are factored. So taking a look at this first guy here, we know it's factored because we've got a product of two factors. So the product means we've got multiplication, and the first factor is x minus 1, the second factor is x plus 2. We know that this is quadratic because if I were to expand it, I would get x squared. The other thing that we notice is that on the left side, or one side, is equal to 0. And if it's factored and one side is equal to 0, we can just guess the solutions for x. So think about what I could put in for x right here. Well, if x is equal to 1, then I'm going to have 1 minus 1, 1 plus 2. The whole equation will become 0 because we have 0 is equal to 0 times 3, and the whole thing will equal to 0. So one solution is going to be x is equal to 1. Taking a look at the next factor, what could I plug in for x right here to make this factor equal to 0? Well, if I plug in negative 2, I know that negative 2 plus 2 is going to make 0. In this other binomial, I've got negative 2 minus 1. So we have, this should be 0. Let's make sure negative 2 minus 1 is negative 3. It doesn't matter what that one is because I know that negative 2 plus 2 will make 0, and the whole equation will equal 0. Left side will equal the right side. So our second solution is that x is equal to negative 2. So those are our two solutions. X is equal to 1, x equal to negative 2. Taking a look at the next guy, this one might be hard for you to guess, and we've seen questions like this before, where if you can't figure out what to put into the x value, to make this factor equal to 0, just pull it out and set it equal to 0. Well, what would x have to be so that 2x minus 1 is equal to 0? Well, let's move that negative 1 onto the other side, or that minus 1, it becomes positive 1. Divide by 2, divide by 2. And we're left with x is equal to 1/2. So that's one solution. If we were to do the next solution, it's going to be very similar. Just set 2x plus 1 is equal to 0 and solve for x. So we have 2x is equal to negative 1, divide by 2, and we have x is equal to negative 1/2. So those are our two solutions, 1/2 and negative 1/2. An easier way to write that is just that x is equal to plus or minus 1/2. Taking a look at our last example, what are the solutions to this system? Well, we know x plus 4 to the power of 2. That just can be written as x plus 4 times x plus 4. So if you recognize it better this way, now let's take a look at what can I put in for x here to make this factor equal to 0. Well, I know that I can put in a negative 4 here, and that factor will become negative 4 plus 4, which will equal 0, and 0 times anything will equal 0. So know that one solution has to be that x is equal to negative 4. How about the next guy? Well, it's the exact same. If x is equal to negative 4, negative 4 plus 4 will also equal 0, and the entire equation will be 0. So we only have one solution here. It is x is equal to 4. So the problem is not solving equations once it's factored. The problem is, how are we going to get it factored? So if I show you an equation that looks like this is a quadratic equation. Not only is it quadratic, there's two terms with x in them that we can't collect. We can't bring these together and make one x and isolate for x. So our only way to solve this is to factor it. So we've learned one technique so far, which is common factoring. But if you take a look, these three terms don't have any common factors. So common factoring isn't going to help us solve this. So we need another technique. And that technique that we're going to work on is called decomposition. And a shortcut is sum and product. And we're going to look at that later. So in decomposition has a few steps. I have them listed over here if this helps you. We're going to go through them together. So the first thing to do is to find two numbers that multiply to a and c. Well, what are a and c? Well, another word for or term for expanded form is called standard form, and it looks like this. We have an x squared term, and then an x term, and then a constant. So standard form, in standard form we can see that a is defined as the coefficient of x squared, b is defined as the coefficient of x, and c is the constant. So this is what I'm referring to when I talk about a, c, and b. So let's go back to the steps of decomposition. The first step is to find two numbers that multiply to a times c and adds to b. So let's figure out what the heck is a times c. Well, we know that a is our coefficient of x squared. So our a must be 1 and our c must be 6. So this guy is our a and this guy is our c. And we need to find a number that multiplies to a times c. So multiplies to 1 times 6, and 1 times 6 is 6. So we're looking for two numbers that multiply to 6. That's easy. But they have to add to b. So they have to add to this middle term here. So they have to add to 5. What are these two numbers? Well, 3 times 2 is 6, and 3 plus 2 is 5. So our numbers must be 3 and 2. So our first step is done. We found two numbers that multiply to a times c and adds to b. This guy right in the middle. So I should have underlined that. Let me just remind you, this guy is b. So our next step is to rewrite the expression and replace the b term in the original expression with the two numbers that we found here. So we're going to replace 5x with 3 and 2. So let's rewrite the rest of the equation. On the left side we have 0 equals, our first term is x squared, or 1x squared. Well, then we're going to break up this middle term, or decompose it into 3 and 2. So we're going to take this b and change it from 5 to 3x plus 2x, because that's the exact same thing. 5x is the same as 3x plus 2x. So we're going to rewrite it x squared plus 3x plus 2x, and don't forget to write the plus 6. So we haven't actually changed this equation. We have 0 copied equals x squared, and then we took this 5x and we changed it to 3x plus 2x. So it makes 5x, and we have a plus 6. So the next step is to factor by grouping. So that just means that we're going to common factor, but we're not going to common factor the entire equation because there isn't a common factor. We're going to put the terms in groups, and we're going to group the first two terms together and the second two terms together and then common factor. If we do this right, something beautiful will always happen. So let's take a look at these first two terms. What do they have in common? Well, they each have an x, so I'm going to write an x first. And then I would be left with an x plus 3. If that's still difficult for you, then go back to the common factoring video. Make sure that you get that perfect before trying decomposition. Taking a look at the next guy. What do these two have in common? Well, they have the number 2 in common. I can factor out a 2, and I'll be left with x plus 3. Do you notice something beautiful that has happened? Taking a look at this term and this term, now they have x plus 3 in common. So they've got this guy and this guy in common. So we're going to common factor it one more time. This will always happen if we're using decomposition properly. Once we group and common factor, there's going to be a factor they have in common. And so what we're going to do is we're going to take out what they have in common. So take out the x plus 3. So we took out the x plus 3, and then what's left over? So what's left over in this term here if I take out an x plus 3? Well, we have an x that's left over. And how about this guy here? What's left over in this term if I take out an x plus 3? Well, we have a plus 2. So let's write what's left over. In the first term, what's left over is an x. That's where that guy came from. And the second term, what's left over is a plus 2. So these are our blue guys. And guess what? We have factored this. So if we go back, remember this is what we started with. When I expand this, I better get this again. And I have x times x, that's going to make x squared. I have x times 2, that's going to make 2x, plus 3x is going to make 5x, and then 3 times 2 is 6. So our final step is just to solve this. So we're going to look for a solution that I can put in here so that the entire equation is equal to 0. Hopefully this should be more obvious to you now. The first solution is going to be that x is equal to negative 3. And then we have a second solution that x is equal to negative 2, since negative 2 plus 2 will make 0. And we have solved this quadratic equation. So let's keep trying a few examples. If you're feeling confident with decomposition, pause the video and try all these examples on your own and just come back just to check your answers. And if you got something wrong, then rewind and figure out where you went wrong and how we did it. Just a reminder before you leave me, remember to always try common factoring first. Sometimes we can't use decomposition right away. By the way, if you notice, we can only use decomposition when we have an equation that looks like, first of all, 0 on one side, and it's in standard form, ax squared plus bx plus c. So we have to have an a b, and a c. So for common factoring, it doesn't have to look like anything. We can common factor anything as long as there is a common factor. So let's take a look at this example here. First of all, let's try to common factor this guy. Is there a common factor? There is not one for all three. You could say x, but 8 doesn't have an x. Maybe you said 2, but x squared doesn't have a 2. But this is in standard form. So we have an a value, we have a b value, and we have a c value. So we can use decomposition. So let's go ahead and try it. If you need help with the rules, go back to the previous page and help yourself out. But the first thing we need to do is find two numbers that multiply to a times c, and a is 1 and c is -8. So what is 1 times -8? Well, that's just -8. So we need two numbers that multiply to -8 and add to our middle number b and add to -2. So can you think of those two numbers? Well, we know that 4 times 2 is 8 and 4 minus 2 is 2. So we know that the answer probably involves a 4 and a 2. We just got to figure out one of these guys has to be negative since they have to multiply to -8. So it makes sense to put the negative in front of the 4 because -4 plus 2 will make -2 and -4 times 2 will make -8. So our next step is to break up this middle term, -2x, into -4x plus 2x, which are those two numbers that we found over here. So let's rewrite this equation with our two new numbers. So we've got 0 equals x squared. We're breaking up that -2 into -4x plus 2x, and then we have this -8 beside it. So our next step is to group. So we're going to put our first two terms together and our second two terms together and common factor. And it doesn't matter the order, whether you put the -4 first or the 2 first, or you flip them, it doesn't matter. You're going to group it and common factor, and we're going to get the exact same answer. So taking a look here, our common factor would be x. I'm going to take out an x, and we're left with x minus 4. And then taking a look over here, we're going to common factor to 2, and we're left with an x minus 4 again. Something beautiful has happened, because what do you notice about these two terms? Well, now they have an x minus 4 in common. So we've got an x minus 4 here and x minus 4 here, so let's common factor that out. So we're going to take out an x minus 4. And then what's left over? Well, we have an x left over in this term and a plus 2 that's going to be left over in this term. So when I take out an x plus 4, I'm going to be left with x plus 2. So I'm going to write x plus 2. And now we factor this guy, and you can check by just multiplying. X times x makes x squared. X times 2 is 2 plus -4x. That's going to be -2. And then we have 4 times 2 is -8. Boom. So let's finish this off. The whole reason why we're factoring is to solve this thing. So we have our first x value is 4, because if I put 4 minus 4, it's going to equal 0. And our second x value is going to be -2, because -2 plus 2 will also make 0. All right, the next guy here. Let's solve this equation. When will this equal -36? Well, we can't combine them. We could just guess and check, but we could be here forever. A way faster way to do it is to factor, but this looks funny. This is not in standard form. Even if we were to factor this, because maybe you said, oh, that's a common factor. I can do a minus 13. You're not wrong. Equals -36, but how fun is it going to be to guess the value of a, so that minus 13 times that value of a again is going to be -36. So that is just a waste of time, and it's so much easier if we do one thing, and that thing is just to make one side equal to 0. So I'm going to bring that -36 over and set it equal to 0. All right, so now I move that negative 36 over, so you should get positive 36. And now this is in standard form. Instead of x, we have a. Not a big deal. If a bothers you so much, cross it out and put an x, but it's the exact same thing. So we have a trinomial. It's in standard form. We have our a value. Our a value is 1. Our b value is negative 13. Our c value is 36. Use the steps of decomposition and factor this yourself. Once you're done, come back to the video and check to make sure you got the same answer. All right, so here's our final solution. If you got this perfectly, move on to the next one. If you had any trouble, let's figure out where you went wrong. So first of all, did you say that you're looking for two numbers that multiply to 36, positive 36, and add to negative 13? And did you choose the right numbers? Because these are the only numbers that will work. If you picked any other combination, go check your math again. Something doesn't add up. So now that we know, by the way, both of them have to be negative because they multiply to a positive number and they add to a negative number. So we broke this negative 13 up into negative 4a, negative 9. Did you make sure you put negatives in front of the 2? By the way, if you put negative 9 first, you should still get the same answer. And if you didn't, there's a little algebraic error somewhere. Then we're grouping the first two terms together and the second two terms together. I'm going to common factor out an a. So we're left with a minus 4. Anytime we're common factoring two things and the beginning number has a negative value, take out that negative value. So instead of taking out a 9, take out a negative 9. And when you take out a negative 9, you're left with, again, a minus 4, and magic has happened. So now both terms have a minus 4 in common. So we factor out that guy, and in this guy we're left with a, and here we're left with negative 9. Did you make sure you put a negative 9 there? You can expand this guy to make sure that you've got it right. And we know our answer here, because the right side is equal to 0. A can be 4 or A can be 9. So let's work with some bigger numbers. So first it says, here it gives us an equation. It says solve when y is equal to 0. So let's first do this quick 7. So we have y equals 0. So we have 0 equals 3x squared plus 11x plus 6. So now we're just dealing with some bigger numbers. We have an a value that's not 1. No big deal. We're just going to follow the rules. So we know that we're going to find two numbers that multiply to a times c. So multiplies to 3 times 6, which is 18. And adds to our b value, which is 11. Think about what those two numbers can be. Things that multiply to 18 are 9 and 2. Could that add to 11? Well, yes, it can. So we already have it. 9 and 2. And then start the steps of decomposition. Finish it all the way to the end. Come back to the video to check your answer. Okay, if you're back, you've tried it, you finished it. If you had the exact same answer as me, so the same factors and the same solutions, you're good. Move on. Go to the next one. If you had any trouble, let's figure out where you went wrong. So our two numbers are 9 and 2, so we broke up that 11x. Doesn't matter the order. You could put 2 first, you could put 9 works, whatever you want. So here, if we common factor this guy, we have a 3 and an x that both these terms have in common. So when we take out a 3x, we're left with x plus 3. Here we have a 2 in common, so we took out a 2. And we're also left with x plus 3. Magic has happened. These two factors match, so we took it out. And we're left with 3x plus 2. Boom. We can expand that guy. It's going to give us this. So now maybe you find this challenging, finding the zeros. This one's easy. Or not the zeros, the solutions. This one's easy. We know that x is equal to x can be negative 3 because negative 3 plus 3 will make 0. How about this guy? If you have trouble visualizing it, remember I already showed you what to do. Just set him equal to 0. Set this guy equal to 0 and say, well, what does x have to be to make this 0? Start solving. So bring that negative 2 over. Get rid of that 3, and we have x is equal to negative 2 over 3, which is how I got this solution. We are on a roll now. Hopefully you're feeling a little bit more comfortable. Let's take a look at D. Okay, this guy looks a little funny. Hopefully you noticed, no point in factoring this guy because we got a 2 over here. What's the point of factoring if we can't guess and check the answers at the end? So one side has to be 0 for us to do that. So let's first move that guy over. So we're going to have 0 is equal to 4x squared minus 8x. And then we have negative 3, and then we're going to subtract a 2. And so we're going to have negative 5. All right, from here, let's figure out if we can use decomposition. By the way, in my head, I'm looking, is there any common factors here? Nope. No common factors. So we're going to look for two numbers that multiply to 4 times 5, and that's going to be 20, and adds to whatever our middle term b is, which is negative 8. And are there such numbers? Well, what comes to mind when I think of 20 is 4 and 5. Even if you add them or subtract them, you're never going to get 8. What about 10 and 2? Could you ever get 8? Well, when you subtract 10 and 2, you can. So let's try 10 and 2. So we have a positive 20, the product is 20. So these either both need to be positive or both need to be negative. Well, 10 plus 2 is not negative 8. Negative 10 plus negative 2 is also not negative 8, it's negative 12. So if we go through all the factors of 20, this is actually not possible. So therefore, this is not factorable. That doesn't mean it's not solvable, but it means that we can't figure out a solution using factoring, and so we're stuck and we can't solve right now. We're going to need another technique, and we're going to deal with that in a few lessons from now, but all we need to know right now is it's not factorable. We can't solve it right now. Let's try another one and see if we can factor this guy. So does this look funny to you? Maybe you think it's funny because of the y, but just think of y as any other variable. If it bothers you, put in x. But does this look like normal standard position expanded form? Well, we got y's in all of the terms, which means that for sure there's a common factor here. And also 3 can be factored out of all of these. So remember, you got a common factor first in order for us to use any other sort of factoring. So let's take out what is in common with every one of those terms, which is 3y. And the first term will be left with y squared, and the second term will be left with negative 7y, and in the third term we're going to be left with negative 8. And now that we have this factored, we're going to leave the 3y alone and just look at this guy here. So we're going to imagine that this 3y isn't even here. We're just going to keep copying it down as we go, and we're going to factor this guy here. So using decomposition, we're going to look for two numbers that multiply to our a value. So multiply to 1 times negative 8. So that's going to multiply to negative 8. And add to our b value, which is negative 7. Can we think of these two numbers? So if you tried the numbers on your own and you came up with it yourself, you get negative 8 and 1. So negative 8 times 1 makes negative 8. Negative 8 plus 1 makes negative 7. We can go ahead and break up this middle term, negative 7y, into the two terms that we found. So we'll do it in blue. So we've got negative 8y plus 1y, and we're going to rewrite it. So don't forget, when we're rewriting it, and we already have a factor out, make sure you just write that first. So we've got 3y, and then we've got y squared broken up. We've got negative 8y plus 1y, and then we have a negative 8. We know our next step, group and common factor. So we have 3y. We have y in common in these two terms, and we'll be left with y minus 8. In these two terms here, we have nothing in common. We have a 1, and if there's nothing in common but a 1, take out a 1. So we're going to take out a plus 1, and we're left with y minus 8. If this is bothering you with all the extra brackets, we could put square brackets here. And magic has happened, and a common factor has come out of both of these terms. So we have a 3y. Let's take out a y minus 8. And what would we be left with? Well, in this term we're left with y, and in this term we're left with plus 1. So we're left with y plus 1. So let's figure out what all the solutions to y are now. We have 1, 2, 3 y's. So we actually didn't factor a quadratic. We actually factored a cubic function, a cubic relation, which we haven't even looked at yet. But you can use factoring for any type of relation, especially if we can common factor it. Then we can do it just using decomposition. So let's figure out what y can be to make this entire equation equal to 0. So what can y be right here? Well, 3 times 0 will make 0, and the entire equation will become 0. So one solution we know is y equals 0. How about this guy? Well, If y is equal to 8, 8 minus 8 is 0. So we know one solution is 8. Take a look at the next guy. If we plug in y is equal to negative 1 plus 1 will make 0. So there are three solutions. Y can be 0, 8, or negative 1. We've got one final equation I want you to try. Well, expression. And it's a challenge problem, and it says factor this expression. So what is so weird about this? Well, we've got two variables going on. We've got a and b. So maybe there's something I can common factor. Do each of these have a? Well, this term has a, this term has a. This one doesn't. What about b? Can we common factor out a b? This one has a b, this one has a b, this one doesn't. So there's nothing to common factor. But I do sort of see a standard form. I do have an a. Here's my a. This is sort of my b, and this is sort of my c, except it's not a constant. So let's try decomposing it. And we know we can always check if we've got it right by just expanding it after. So let's just use the rules of decomposition. So we would be looking for two numbers that multiply to 7 times negative 6. So they're going to multiply to negative 42. And add to our middle term b, and adds to 19. If you play around in your calculator a bit, you know that 42 divided by 2 is just 21, and 21 and 2 might make 19. So let's figure out where a negative might go. We need to make negative 42 and positive 19, so if I put a negative here in front of the 2, let's just check. 21 times negative 2 will make negative 42. 21 minus 2 will make 19, so we found it. So we're going to break this guy up into two new terms. So we're going to put 21 plus, sorry, not plus, 21 minus 2. But what's our letters? Our letters A, our letters B. Well, we need to make whatever here equivalent to this. So this must be 21AB minus 2AB. So that when we subtract them, we get 19AB. So let's rewrite this whole thing. Notice how I don't have 0 over here. So I can't solve for this because I've got two variables, which is why that just says factor. So we're just going to leave this blank on one side just so that we can practice factoring something that looks like this. So I've got a 7a squared that I'm copying down first. Then I'm replacing this middle guy with these two here. So we've got plus 21ab minus 2ab. And then I have minus 6b squared. It looks odd, but let's go with the next step. The next step is to group and common factor. So I'm going to group the first two and the last two. Take a look. The first term has a 7 in common and one a. So let's take out a 7 and an a. And I'm left with a plus 3b. And then the next guy, first of all, my leading coefficient here is negative. So I better take out a negative because I want whatever's left over to start with a positive. And they have definitely negative 2 in common and also a b. So I'm going to take out a negative 2, and here I'll be left with a plus 3b. And magic has happened. A common factor, a common binomial has come out of these two terms. So we're going to take out our common binomial, our common factor, which is a plus 3b. And write what's left over. Left over was 7a minus 2. So left with 7a minus 2. And we think we're done, but let's expand this to triple check. So if I just work over here, I'm going to work over here in blue. Let's expand this thing. So our first term, if we were to multiply a times 7a, would be 7a squared. Then I would do a times negative 2 and then 3b times 7a. Oh, something's wrong. I realized I made an error. When I took out a negative 2 out of here, I meant to take out a negative 2b, which I think I said, but I just didn't write. So maybe you're yelling, "What, miss? You're doing it wrong." You were right. So what what was in common was a negative 2 and also a b. So I took out a b. Good thing we checked, otherwise we would have missed that mistake. So let's put in a b here. Okay, so now let's keep expanding. So I've got a times 7a is 7a squared. A times negative 2b is going to be negative 2ab. Next I have 3b times 7a. So we've got plus 21ab. Notice, don't these look familiar? Don't these look like this? Okay, and we got 3b times negative 2b is going to be negative 6b squared. And when we simplify, we're going to get 7a squared plus 19ab minus 6b squared. So a challenge problem and something for us to recognize is we can use also decomposition when we have two binomials that might just have two variables, but they're like split on either end. So we have an a here and a b here and an a here and a b here. When we expand it, we're going to get the first variable squared and the second variable squared and a combination of the two in the middle. So if we notice that, a squared and a squared, a combination of the two, we can also factor it by decomposition.